Alright guys, so our next part of the chapter is 9.11 and it's called Purity of Sample. In my textbook, or in our textbook, I'm on page right now 359. Okay, so when you get the chemicals in the lab or in production, you don't get pure chemicals most of the times, unless you're doing some pharmaceutical ingredient testing, which is API or called active pharmaceutical ingredients. Those are usually supposed to be very pure samples. And even those at times come impure. And the way we handle those samples is we pretty much get the percentage of the pure active ingredient and the total sample which contains some impurities. For example, let's solve example 9.16, and then you will see what I guess I mean by something that is impure, and how to calculate, for example, how much of the pure substance in the sample and how much in terms of grams or percentage of the impure sample. Okay, so let us say that we have a 32.00 grams of just a sample, and what that implies is that this has a pure component of the sample, component of a sample, plus impurities. And there could be many impurities in the sample. So in order to figure out the impurities, I guess, in the sample, you will have to do some chemical analysis to determine that. Now, but they will also give us that the sample is 96.20% has purity by mass. So what does it mean by mass? Usually you will see something like weight by weight or m over m, mass by mass. It means you got grams of the pure sample, in this case 96.20 grams, and the sample we're discussing here is nitric acid. My apology, my pen just slipped. Which is HNO3, nitric acid. And so when the tell is 96.20% purity, that means we got 96.20 grams of HNO3 over 100 grams of just a sample. And what this sample contains the pure HNO3 plus all bunch of different impurities, okay? Now, how do we now solve problems with this given information? All right, so this is nothing else, as we learned before. Once you got a ratio, one unit over the other, this is what's called a conversion factor. All right, let's see how we can use it. So, are we given any amount of sample? Sure we are. We're given 32.00 grams of sample. What that means is that this sample contains pure and impure components of it, times. All right, so all we need to do is find out what we need to figure it out. It says in the question, calculate the following for this sample of nitric acid. Well, the first 8 says the mass in grams of HNO3 present. Okay, great. So remember, guys, I'm going to go all the way here now, and I'm going to state the units that I want in the end. All right. So I want grams of HNO3 in this particular sample. All right. So what I got here is I got my conversion factor. And this looks like I don't need, I guess, so much space in here, but I already kind of used it. So let me just do the calculation. I know that 100 grams of this sample that contains the pure and impure components of it. You see how I lined up the units that I want to cancel, canceled, and it contains 96.20 grams of the pure component, which is nitric acid in our case. So I guess what I can do now, I can bring this closer now, because all I'm doing is pretty much in the one-step conversion. And again, this I unit here is grams of HNO3, and all I have to do is just, the little mathematics here. And again, I'm going to use my calculator. I'm going to say 32 multiplied by 96.2 divided by 100. We will have to assume this is an exact number. It's 100%. It's out of these perfect 100 whole thing. This contains 4 significant figures. This contains 4 significant figures. And so it looks like my final answer has to be 4 significant figures. And in this case, this will be 30.78 grams of HNO3. Okay, awesome. So we just got in the impure sample, 32 grams of that sample. It contains HNO3. And some impurities we were able to figure it out based on the percent of the purity by mass in the sample. And remember, by mass means mass by mass, or in this case, grams over grams, that's mass by mass. And so we were able to figure it out how much of the pure HNO3 contains in 32 grams of the sample. So our next question, B, asking the mass in grams of impurities present. And so this one, again, we can do several ways. One of the ways, we can just say that 32, so now mass of impurity equals to, we're going to take now the entire mass of the sample, 32.00 grams of the sample. I just abbreviated sample as SPL. And I'm going to do minus 30.78 grams of pretty much HNO3. And so the rest, whatever's in the sample, will be our impurities. And again, I'm going to use my calculator now to perform this action here. 32 minus 30.78. And so what I got here is the 1.22. Again, I'm subtracting, I'm using the precision now rules in terms of significant figures. And my precision here in the hundredths place, this one in the hundredth place. So my final answer will be expressed in the hundredth place. And that will be so many grams of impurities. What's another way of solving this problem? Another way I'm talking about to get the grams of the impurities. You know that you have 96.20% of the whole thing. So what you could have done, you could have just subtracted from 100% 96.20%. You would have gotten the percent of impurity, and you could have just multiplied, create the conversion factor as it did for the pure substance. And you're going to convert it now from the whole thing. So let me just show you a little, a little better explanation here. So I'm going to do 100% minus 96.2%. So I get 3.8%. And I'm going to multiply now this by 32 grams. And I'm going to get now the number here. But remember, I use the percentages here. So basically, you will have to divide it by 100 to get the actual result, which also came out to be pretty much 1.22 grams of impurity.